1 o'clock. I guess we'll get started. First thing I need you to do is, can somebody explain to me what a Karen is? A Karen?
Entitled white lady.
Entitled?
Why do you have that question?
Because I keep hearing it all over the place.
So where it started from was, there was a lady that called the police and reported that there were some black gentlemen barbecuing at a park that said there was no barbecue. So it just was a big meaning that, you know, Karens are calling the police on black people for doing stuff that everybody does. And that's where it came from. That was just,
It's bigger than that, though. Like, a Karen is literally any entitlement. Like, they talk about the Karen haircut, that weird bob.
but it's bigger than that now, but that's where it started. It was starting where those guys were barbecuing and letting the police on the barbecue at the park.
Okay.
And then it's just, they're saying don't be a Karen, look like, just like, don't be that one that's trying to ruin everybody's fun, pretty much. For the most part.
Like an entitled white tattletale.
Just a type of person, period, now. It's just, not anybody can be a Karen. That's
So-
where it started.
All right. So, okay, now, show of hands. Ben Meyer is a Karen.
No, Ben Meyer's a Chad. Ben Meyer is a Chad.
What's a Chad? No, what's a Chad?
It's a British thing.
Real name of you?
A Chad is like a guy who does obnoxious stuff. Like, there's a way they look too, like they wear athletic tracksuits.
Yeah, that's Ben.
Yeah, Google Chad, and you'll probably get some good results. Or you'll get like election results from what, 2001?
Hanging Chad.
Hanging Chad, exactly.
Internet slang, generally sexual.
Oh, I'm out.
Whoa.
Oh, I'm confusing Chad with Chav.
Chav?
Yeah, with a V. Chav. There we go.
Charver, Scally, and parts of you. Antisocial lower class youth. Okay. Oh. Hashtag Ben Meyer right there. Okay.
Hi, Zach. I'm here.
Oh,
My sink or my bathroom sink is exploding and stuff, so I might be in and out talking to the guy, but I'm really glad you're Zooming, so
okay. Welcome.
I will be here.
We're on slide number 38. Nope. Sure not. Yes, we are. These first several, so I want to get through this today, and we'll plan on taking the quiz Wednesday as long as we do. These first several, I'm going to go through sort of quickly. That's a hint, and then I will slow down for a few slides, and that is also a hint. So where we left off the other day, I think, talked about the load on a motor increasing, and then the startup torque of the motor is, we came up with more than full load torque. It's not zero, it's not more than stall torque, and it's not less than no load torque. So horsepower depends on the speed and the torque of the motor. The speed of the motor will deliver certain horsepower. If no load applied, a motor is exerting no torque, and the horsepower output is 0. Locked rotor condition, stall and start up, the motor is not doing work, so the horsepower delivered is also 0. No work is being done. So you can think of horsepower as work. But locked rotor condition, how much current is there? Is current high or low?
That would be high, right?
Very, very high, yeah. Here's a little graph of torque with speed. As speed increases, torque decreases, current decreases. But at lower speed, you have high torque and high current. Impedance, what does impedance mean? Chav, what does impedance mean, Chav?
Impedance. Resistance of either kind.
You just read the slide. Remember AC theory? When you find Z, impedance is a resistance, but it has to do with alternating current. Because remember, with impedance, you have things like inductive reactance, capacitive reactance. So if you have DC current, then you're talking about pure resistance. With an inductive anything, an inductive load, there's going to be something called impedance. So any resistance or impedance is just resistance to current flow. DC motor that is stalled has an impedance that is only the resistance of the windings and brushes. Impedance of an AC motor that is stalled includes its winding resistance and the inductive reactance of its windings. Remember when you were doing all that AC theory crap and you're like, why am I learning this? Here's another reason. Huh? Yeah. Impedance is low at stall, which is why it draws high current. As its speed increases, there is an increase in electromagnetic induction, which causes the motor impedance to increase.
I've got an AC question about that. What's the difference between impedance and resistance? Is it one and the same?
I just explained that.
Kind of do. But is there-
Is calculating impedance part of finding torque? Because that makes me scared.
No, this is sort of informational purpose only, but it'll help you understand.
Impedance traumatizes me.
When you go through AC theory, you measure impedance and you're also, measuring or getting that to a volt. So there's two different. I forgot what they said.
Think about it this way. If I have a long piece of wire, just copper wire, no load, no light bulb, no motor, no nothing, and I put AC current on there, what is that? What is that current going to be? What's it going to do? Is it going to be small, big?
It's going to change. It's going to create a magnetic field as it goes up and down, just like that sine wave.
Yes, but if you know, let me back of that ass up. I need some space here.
It'll start high and then it'll go down lower.
Take all of this with a grain of salt, okay? Because you don't need it for the quiz, but it is important to know. So I have 10 foot of copper wire right here. And I put AC current on here. Whoops. What do you think the current is going to be?
Is it
Very,
connected?
very, very high.
Okay.
There's very small resistance. If I take that same piece of wire and I coil it up a bunch of times, and I put AC current on here, what is that current going to do?
It gets a Oh, less.
It's going to be manageable. Yeah. Depending on the amount of turns in the wire. Why?
Because the capital straight has to go through more.
It's not a physics thing. It's the principle of electromagnetism. You're creating magnetism by doing that, right? That impedance is in opposition to current flow. So think about like a relay coil. If I took that, if you put 120 volts on a motor starter relay coil, it's just going to pull in. It creates electromagnetism, right? It's not going to trip your breaker, blow your fuse. If I take that same wire that's in that coil and uncoil it and straighten it out and put 120 volts on it, it's either going to burn apart or blow a fuse or blow a breaker because
It's like basically like simulated induction, sort of.
well, I guess you could think about it like it's doing work, right?
Okay.
You're creating something out of it. You're creating magnetism. It's a phenomenon. Do 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 do.
Phenomena.
Do 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 do.
You
Phenomena.
Do 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 do. Can I get
This
a
is why-
oh
this is
yeah?
why I come to class is you guys and your duets.
I don't have the excuse of having children, so Zach's at least got a pass.
No. So the coil means the impedance is higher, which means the torque is lower. Higher.
What was your question?
So the coiling makes the impedance higher, which makes the torque higher or lower? Or is that just
Yeah,
like
it's
an
nothing to do with torque
okay?
right now.
That was just like okay, got it. So this
That's
isn't
only an alternating current, right? You know that, right? If I take that same coiled up piece of wire and I put 120 volts direct current on it,
yes.
and do the same thing as if it was flat.
Yes.
Alternating current that
Ooh.
creates a resistance to current flow. with a
Okay,
coil.
got it.
And again, that's all for informational purposes.
Yes.
Appreciate it.
Mhm. Now we're going to talk about wattage. So what's the difference between wattage and horsepower?
Wattage is the amount of watts, and horsepower is something that makes the watts do the things.
Did you say you're right? When you talk about just horsepower, you're talking about the amount of work being done in a certain amount of time. So I guess the whole 746 watts and 1 horsepower is a little confusing because you're missing the time reference. But for the sake of calculating current, for instance, calculating current in a motor, a 1 horsepower versus a 2 horsepower motor, using that formula is what you would need 746 watts to calculate, right? In DC motors, voltage times current, that's basic P equals I times E. An AC motor, it's voltage times current times the power factor. Oops.
So can you give a definition of the difference between watts and horsepower then? Just so I can be clear.
Sure. I would say watts equals current. Wait a minute.
Okay.
Watts versus horsepower. Watts is just purely power.
Okay. When horsepower is how much it can do with the watts that it has, or
Horsepower is work over time.
Okay. Thank you.
And a rough equivalent of that is 746 watts.
The watt heat is power density, in order to keep it basic, the voltage times the current times the power factor to get the power.
Right. And take this with a grain of salt as well. Why do we need power factor involved there with AC motors? Because the work that's being done in that inductive process is not pure. You lose a little bit through heat, right? That's where power factor comes. Power factor comes into play in any inductive load. So a motor, transformer, generator, any inductive process, you're going to have some kind of power factor because it's not pure. You have power loss.
So I'm okay. So I'm confused about the 745. So like 1 watt is equal to that much horsepower. I don't understand what that is that you did there.
From the lecture from last Monday,
Okay.
1 horsepower equals 746 watts.
Okay. Thank you. Sorry.
Okay. Using the graph to determine how much horsepower the motor will produce at 1,000 RPM. Pretty easy.
About 4. Let's see.
10.
Oh wait, yeah, wrong graph. 10 that side.
Using the graph to determine how many watts the motor will consume at 100 RPM.
We're looking at 1,000.
1,000 RPM.
So that looks like it'd be about 4 kilowatts. 11. Oh, power factor. Yeah.
Some of you might have been looking at the horsepower graph. At 1,000 RPM, somewhere around 11 kilowatts. Using the graph to determine the motor no load speed and RPM. Yeah, 1,200. I mean, yeah. If you're at no load speed, which you're not consuming any power, you're not producing any horsepower because there's no load, right? So it's I guess it's kind of a trick question, but it's what is the maximum speed of the motor? It's not going to just spin on to infinity. It's going to follow the 60 hertz sine wave and it's going to spin at maximum value. Using the graph, determine the motor maximum horsepower and speed at which it occurs. What you thinking?
That'd be about 16 horse.
Maximum horsepower. So yeah, we're looking at this graph saying how much horsepower can we get out of this motor? The maximum would be around 16 horsepower and somewhere around, what is this? 700 RPM is what it's saying.
Mm.
Using the graph, determine the motor maximum wattage and the speed at which it occurs. About 22,000 watts at 0 RPM. Okay, efficiency. And this is where I'm going to slow things down and hope you pay attention a little bit. The efficiency of a motor based on how much mechanical power it produces for the electrical power it consumes. Makes sense? Expressed in a percentage of the input power. Efficiency equals power out divided by power in times 1,000, times 100. Power out is in horsepower, power in is in watts. To determine efficiency, power out and power in must be converted to the same units. To determine efficiency, power out and power in must be converted to the same units. We just said that. 1 horsepower, 746 watts. Perfectly efficient motor would convert 746 watts of electrical power into 1 horsepower of mechanical power. No motor is 100% efficient. The more wattage it takes to produce 1 horsepower, the less efficient the motor. So, how many watts would I get out of a perfectly efficient motor? 746. This one's not in the slide, but if I asked you what percentage efficiency motor manufacturers are required to meet?
80%,
80%. How'd you know that?
because I'm smart and I learned it in another class.
There you go.
I think Tom's class.
Well, screw that. No, you learned it in Zach's class.
Okay, I will never mention Tom again.
So if I'm a motor manufacturer and you're the authorities and you're testing my motor before I can sell it, what percent efficiency must I meet?
80.
80. Most motors usually run efficiently between 3/4 and full rated horsepower. I guess that's what that's trying to say. And keep in mind, it is that these things are designed to do some work, right? It's going to be most efficient when you put 3/4 to 100% full horsepower on it. And efficiency decreases with both heavier and lighter loads. At startup, when running with no load, a motor has an efficiency of 0 because it is producing no horsepower. But somewhere between 3/4 and 100%, you're going to get that peak of the curve. So if I asked you, when do motors operate at maximum efficiency?
Never.
At their full load speed.
At or near full load speed.
Oh.
No, at or near full load. Speed doesn't matter. This graphic is so terrible. I need to find a better one. Electrical power that is not converted into horsepower by a motor is converted to heat, and I would say lost in the form of heat. When a motor is running with no load, all the watts into it are converted into heat.
When would they be running it with no load? Just like to test stuff or
Yeah, I mean, in real life, you wouldn't
like troubleshooting?
have a motor running just for fun, but
Well, yeah, that's what I was wondering if it was like
yeah.
that was something that happened often.
So any motor loss show up as in what form?
But no one's running a motor with no load like ever.
Well,
normally.
I am because I'm a teacher.
Well,
But
anyways.
motor losses show up as
Okay.
what? Heat.
Okay, got it.
Just to put this as an example, the troubleshooting trainer is mounted on the wall back there. they have those things that I can tighten to put a load on them, but when I run them, when we do our motor control setup and you just hit the start button and that thing just starts spinning with no load on it, is that very efficient? No. Is it producing any horsepower? No, because it's not doing any work. But is there any sort of loss there? There is a loss. And what form is it in? Heat.
Heat.
Sit there and run that motor at 3,600 RPM or whatever it is with no load, you're going to feel it warm up.
And it does when it's running with load too, but just less.
Yes. The heat that you lose under load is that's the other side of efficiency,
Yeah.
right?
Okay.
So at a certain load, a certain speed, you're getting a certain horsepower that it's designed to do. You're going to get the maximum efficiency and the minimum amount of heat loss.
Okay.
But the rated speed and horsepower, wattage is much higher, but so is the horsepower. The difference between watts and horsepower out is moderate, so the heat produced is easily dissipated. Motor operates below its rated speed. The difference between wattage and horsepower out is large. Motor can overheat and damage its insulation.
That's when you're running without the load.
Yeah. Running without a load, too small a load, or too big of a load. There's a range there that you want to try to stay in. And like we just talked about, no, we talked the other day about stall. Like when we're single phasing and you put a load on those motors out there, and you'd hear it make that horrible sound and the motor would start to heat up. It's because there's no horsepower. So the wattage going in is enormous and the horsepower out is zero. So you have maximum heat loss, and that's what ends up tripping your thermal overloads. So basically all of the wattage coming in is converted into heat. All right. Point A is over here, showing no load. B, rated speed and load. And C is stall speed. Okay. So stall speed means enormous current, enormous heat loss, 0 horsepower out. B is this little happy zone here where you got rated speed and load. So you're getting maximum horsepower out of the motor. And
Is that divided by or just also?
Also.
Okay.
And then C is stall speed. So you're running full speed, no load, and you're not getting any horsepower out. So when would a motor overheat the quickest?
Stalled.
Stall speed. The C range right here. So when would a motor overheat the quickest? Stall speed. When would a motor overheat the quickest?
Stall speed.
Anything that interferes with heat loss in a motor will increase the motor internal temperature. Motor fan doesn't turn at rated speed will cause heat buildup. Dirt in the motor, block airflow, the windings, and cause heat buildup. To keep a motor from burning up, follow these guidelines. Do not overload the motor. Maintain the motor, clean it, lubricate it, replace contacts and brushes. I don't know that I've ever seen in the field Most places that run motors a lot will have some kind of preventative maintenance, but I've never seen motor lubrication. I've never seen people checking the bearings.
They don't have people like come in and do like maintenance like that.
The only preventative maintenance that I've seen on motors has been cleaning. And that's at least then you're keeping airflow through the fins of the motor to keep it cool. I mean, it's designed, that's why they put fans in motors, just to keep them cool.
Yeah.
Right, so as you're doing work, they're cooling themselves off.
Okay. And like lubrication? No.
I've never seen that in the field.
Hmm.
But if you have a really expensive motor that you
Probably
own,
wanna do
I
that,
would. Keep a motor from burning up, blah, 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 blah. Anything to reduce friction in the motor will help. When do motors burn out?
When they get hot and frictioned.
Mm-hmm.
When the coils break,
When the coils break, burn out. Yeah, that would. Yeah, that would burn them up. Creating heat enough that the insulation on the windings burns up and they short. That's when they would burn up. But do you think that would be caused by overloads tripping, current being too low, motor running too fast,
Yep.
or being overloaded for long periods of time?
Or having stuff frictioning all over it.
Yeah, but the best answer is being overloaded for a long period of time.
Okay.
Is there
I'm being a Karen.
something in your eye?
Uh-huh.
So I'm gonna write that down. What was the question?
When do motors burn up, burn out, burn up?
They don't, they just fade away.
They don't. That's the correct answer. Yep.
What was the question?
What causes a motor to burn up?
Oh, you guys are just being silly.
When they're being overloaded for long periods of time would be a good answer to that hypothetical question.
Zach, are you having a stroke? Your smile is crooked.
No? Yeah, toast. All right, that's where I'm going to stop. There's a bunch more
Thank
information.
Fucking
The
torture.
rewinding of motors, but I don't see the point in quizzing you on that stuff. It just comes down to.
So we're doing the quiz Wednesday. We have to do it that day. We couldn't do it Friday.
We're doing the quiz Wednesday unless you guys decide as a group vote to do it Friday.
What do you guys think about Friday?
Sounds like Wednesday it is.
Yeah. Meh. I'm just kidding. Okay.
So,
I accept defeat gracefully. So basically, we should know everything from the slides we've gone over.
correct.
Okay. Are we going to be doing?
You don't necessarily need to know everything from the slides. Pay attention to what I said.
Are we going to be doing calculations?